We're going to look at graphing polynomials in vertex form. Now, we've got several different kinds of polynomials. You've already looked at one in a previous class. That's our quadratic, or our x squared, or we also call it a parabola. Okay? So notice the blue one is our x squared. We have the x to the fourth, which is the red one, and then we have the x to the sixth, which you can't maybe tell if I zoom in. There we go. So here we have the x to the sixth, right? So notice that we have that, it's a very similar shape. They're all U-ish shaped, okay? But as we go from a squared power to a fourth power to a sixth power, notice it gets steeper as we go higher in power. And then notice in between one to the left and right of the vertex, remember our vertex is the lowest point or our highest point or the bottom of the U or the top of the upside down UU. Okay? That in between the -1 and 1, the red gets flatter and then the black gets even flatter. So in between your one to the left and right of your vertex, it goes flatter, and then past that, it gets steeper. Okay? Our x to the third, x to the fifth, and x to the seventh, notice we've got this kind of I refer to it as discoing shape, where it kind of looks like the arms that you would make for discoing. Okay, you've got one going down and one going up, so we're discoing. Our x to the third creates this shape. Our x to the fifth is this shape, and then our x to the seventh is this shape. But we have that same kind of pattern where we've got the, as the power goes up higher, then the steeper it gets, and then in between -1 and 1, or one left and right of the vertex, it gets flatter, right? It's not as pronounced on this one, but notice it does get flatter here. Okay? So we have that same kind of shape. So our odd ones have that discoing look, and then our even ones have that U-shaped look. Now, hopefully you remember from your previous class that when you've got quadratics, that you have a times x minus h squared plus k, and your vertex is hk. So if you have your vertex as hk, it's the opposite of inside the parentheses, that goes horizontally, and then it's the same outside the parentheses that goes vertically. And then our A changed the steepness. Okay. Now, if we go and we take a look, so if we come here, you should have already done this as part of the activity. Okay, but here we have an x cubed, right? So if we look what our h does, so if I move my h, notice as I go positive numbers, it moves it to the left, and as I go negative numbers, it moves it to the right. Okay, so we're moving left and right with our h. Notice our h is inside the parentheses. If we take the k shifts it so it's moving up and down. Right? And then our a value, I'm going to put these back more towards the center so we can see what's going on. Our a value, if I put it at 1, okay, no, that was not helpful. Okay. Well, whatever, 0.8's close enough. So as I move it along, it gets steeper. Or if I move this way, notice it flipped, right? We went from this way of discoing to flipping our arms and discoing the other way, right? But it would still, the A is affecting our steepness, right? So the H still changes how far left and right it goes. The K still changes how far up and down it goes. And the A is still impacting the steepness as well as saying which way it goes, right? So if it's positive, it's increasing from left to right. And if it's negative, it's decreasing from left to right. Okay? So if we go back and we take a look, we have some patterns that we have. Now for the quantity squared, your parabola that you had with the squared, you had what I refer to as the 1, 3, 5 trick. So from your vertex, you went over 1 and up 1, and then from there you went over 1 and up 3, and then from there you went over 1 and up 5, right? And then you mirror imaged it because it was symmetrical, and then that made your parabola shape, right? Well, we also have rules or patterns that go with the cubes, the fifths, and the fourths. Okay, so for our cubed pattern, we use 1 and 7. So for squareds, it's 1, 3, and 5, and then we times by whatever our a value is. And then for cubes, it's 1 and 7, and then you times by whatever your a value is. Okay. So we still have that same pattern where on the cubes, you're switching going the opposite direction of inside the parentheses, and then outside the parentheses, you're going in the direction of the sign vertically. And then our a impacts the steepness, and we're going to use our a value with the 1 and 7 trick. Okay? So let's take a look at a couple of examples. So here we have this first problem where we've got x minus 3 quantity cubed minus 1. So we're going to go the opposite direction of inside the parentheses. So we're going to go right by 3 and down by 1. So opposite inside, same direction outside. So we're going to go right 3 and down by 1. Our a value is this unsaid 1. So all I'm going to do is, remember, cubed has that disco shape. So I'm going to go over 1 and up 1. Then from here, I'm going to go over 1 and up 1, 2, 3, 4, 5, 6, 7. And then from our vertex, we're going to go left 1 and down 1, and left 1 and down 1, 2, 3, 4, 5, 6, 7. So we get this kind of shape with our x cubed. If we look at our next one, we are going to go the opposite direction inside. So that means we're going left 7, same direction outside, so up 4. So left 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3, 4. Okay. But this time we have a 2. So I'm going to take the 2 and I'm going to times it by the 1 and 7. So that gives me 2 and 14. So instead of going over 1 and up 1, I'm now going to go over 1 and up 2. And then instead of over 1 from there and up 7, I'm going to go over 1 and up 14, which is obviously quite high, right? So 2, 4, 6, 8, 10, 12, 14, like there-ish. So left 1 and down 2, left 1 and down 2, 4, 6, 8, 10, 12, 14. Okay. And then I make this shape. Oh, I missed that. Okay. Now, when it goes super far off the graph like this, you don't need to do that. You should have at least 3 precise points. Now, I know it goes this direction instead of coming this way because the a is positive. So if the a is positive, remember your a positive looks like this. If your a is negative, it'll look like this. Okay? So see if you can find the vertex for the next one. So when we're finding our vertex here, we're going to go the opposite direction of inside the parentheses. So we're going to go left 1 and then down by 6, same direction outside the parentheses. So left 1, down 1, 2, 3, 4, 5, 6. Okay. The a value is a negative 1/7. So I'm going to do negative 1/7 times 1 and 7. So negative 1/7 times 1 is negative 1/7. Negative 1/7 times 7 is negative 1. So we're going to go, now normally if it's a is positive, it's this direction. We're going to flip it around and go this direction. So I know that as I go to the right, I'm going down. Or you can think we go over, and then if it's negative, it's down. If it's positive, it goes up. Either of those is fine. So over 1, down a 7th, which is obviously just a little smidgen. And then left 1, up a 7th. Then from those points, I'm going over 1 and down 1, which just puts me a smidgen past the next tick mark. Right? So this is less steep, right? And it's also going the other directions, decreasing. So negative is decreasing from left to right, and positive is increasing from left to right. Now see if you can find the vertex for the next one. Okay, so on this one, we can do the opposite direction of inside the parentheses. So right 5, same direction outside. There's nothing outside, so it's really a plus 0. So we're going right 5 and up nothing. So write 1, 2, 3, 4, 5, and up nothing. Okay. Our a value is the unsaid -1, so I do -1 times 1 and 7, which gives us -1 and -7. So again, because it's negative, the a value is negative, that means I'm going to be decreasing. As we go to if a is positive, rather, we're going to be increasing. So I go right 1, down 1, right 1, down 1, 2, 3, 4, 5, 6, 7. Or from our vertex, left 1, up 1, left 1, up 1, 2, 3, 4, 5, 6, 7. Okay. And that gives us our graph. So that's how you graph your cubes. Now, if we look at the domain and range, remember your domain is how far left and right it goes, and the range is how far up and down it goes. So as we're going here, I mean, it will take a while to get over because we're going up so quickly, right? But we'll continue to have this value as we go left and right, okay? This continues to go left and right forever, left and right forever, left and right forever. So our domain on all cubes, or cubic is what we call them as well. The domain is all real numbers or -infinity to infinity. The range, remember, is your y values. So all of these are spanning all the way up and all the way down. So our range for all of these is -infinity to infinity. So remember, for your cubes, you've got that disco shape. If your a is positive, then it's increasing from left to right. If your a is negative, then it's decreasing from left to right. And then in your vertex, it's the same way that you get your vertex for your quadratic, where you do the opposite of inside the parentheses, same on the outside. And that's how you graph those cubes.